Hello guys, welcome to NS Academy. So today we are going to discuss about definite integration, and I have picked a lot of problems from previous year JEE advanced papers, and we are going to discuss how to do this definite integration problems, how to tackle them. So whenever you get a integration problem like this in your papers, for example this was in I think 2024, and this looks like a complicated one. You are given a function f which goes from like 0 to pi by 2 to 0 to 1. It's a sine square x, and then you again have a function of g of x which is root over pi x by 2 minus x square. And you are asked to find this integral where like 2 0 to pi by 2 fx dx minus 0 to pi by 2 gx dx. So okay, this looks complicated, but always remember a few rules. If you get something that looks complicated and you cannot do it immediately just by looking at it, always understand, because you're giving like exam like JEE advanced, which is below college level. Okay, in any exam that you encounter up to high school, no question can ever be tough. Remember this. If you think this is tough, that means there is some sort of trick that you're missing here. That's as simple as it is. Okay, let's see. You have this. What I'm going to do simply is I'm noticing that obviously I can take g of x dx common here, obviously not the integral, but we can take the integrals inside because both have the same limits. So if you do that, you get 0 to pi by 2, 2fx, I think not 2fx, so what we can do is gx common, 2fx minus 1 dx, right? This is what we get if we get everything inside. Note, the most important property that is always used in definite integration is this. When you have, I will write it here in small, a to b f of x dx is always equals to a to b f of a plus b minus x dx. This change of variables is very important, always remember. Replace x with a plus b minus x. We are going to do exactly the same. You see, this is what we have here, right? This is also I. Now what is g of x? G of x is this function. Now you can see the function is made in such a way, you can write the function as pi x times pi by 2 minus x, and this function is simply 2 sine square x minus 1 dx. And if you apply this thing here, you simply get 0 to pi by 2. Notice this function does not change at all, g of x does not change. So basically g of x is equals to g of pi by 2 minus x, but this one does change, and you have x whole into pi by 2 minus x, and here you have 2 cos square x minus 1 because sine of pi by 2 minus x is cos x, right? And this is also I. If you add this to instances of I, you simply get 2i equals to 0 to pi by 2. I will write this as gx, and inside you get 2 sine square x plus 2 cos square x minus 2, and you can understand that 2 sine square x plus cos square x minus 2 dx. This is also 1, so 2 minus 2 is 0, the answer is 0, I is 0. So okay, let's move on to the next example. Okay, so here is our next problem. This is a problem from the JEE Advanced 2020 paper. So you can see we are given a capital F function which goes from 0 to pi to the real numbers. The function is defined as 0 to x ft dt for some other function small f, and it was also given that f is a continuous and differentiable function and its derivative is also continuous. We were additionally given that f of pi is minus 6. We need to find the value of f0 if this relationship is satisfied. Again, all the information is spoon-fed to you. You just need to identify what to do. Just like in the previous problem, this is not going to be a hard problem once you identify the strategy. See, f dash x, I'm just trying to explain how to get to the point where you can solve it. F dash x is given and f of x is given. You can understand from the fundamental theorem of integral calculus that f dash x is basically fx. So you understand that f dash x is small fx, right? So this you understand because by the Leibniz rule of differentiation. Now you are given a function. Now f dash, if you do the small f dash x, it would be f double prime x of capital F. So that basically gives you a double derivative, but we do not want that. But we have a tool at hand called integration by parts, which can change and integrate and differentiate functions according to our needs. That is why an extra cos x is also given, which can be both integrated and differentiated. That's what we are gonna do. We are gonna basically separate this to integrals like 0 to pi f dash x cos x dx and plus 0 to pi capital F of x cos x dx equals to 2. Now once you have this relationship, you have to understand that in one of these functions we are gonna take this f function as the first function, and in another one of the functions we are going to take it as the second function in integration by parts. Why? So here we have f dash x. If we take this as the second function, then this would be integrated to f of x. And in this one, if we take this as the first function, this would be differentiated and we will get f of x. Once you realize that, the whole problem becomes very simple. Let's do that. So in this one, this is first, and then this one, this is second. Okay. So this one, what will we get? This one will get cos x into integration of f dash x is fx, and we will evaluate this from pi to 0 minus 0 to pi. And now differentiation of the first function, cos x differentiation is minus sin x, minus and minus plus sin x into f of x dx, right? Now go to this one. Here we have plus fx into integration of cos x is sin x, so capital Fx into sin x, and it goes from pi to 0 minus 0 to pi, and again differentiation of capital Fx is simply small fx, so small fx into integration of cos x is sin x dx equals to 2. You simply see these two integrals cut directly. And again, when you evaluate this, sin pi and sin 0 are both 0, so this is also 0. What is left is this term. So cos pi f of pi, cos pi f of pi plus cos 0, minus cos 0 f of 0 equals to 2. You know cos pi is minus 1, f of pi is minus 6, this is only 1, so this is basically minus f of 0 equals to 2. We simplify this is plus 6, this is plus 2, you get the value f of 0 as 4. It took me some time to actually write it all down, but in an actual exam paper you would just race through the steps and you simply have to find out what is important. So you know that this is going to cancel, you are not going to write all the steps, and this can be solved in under 1 minute or 1 minute 20 seconds. And if you are fast enough, you can even solve it under a minute. So you see, basic concepts, properties of definite integrals, integration by parts, these things are used and these problems can be solved very easily. So okay, I'm trying to keep this video short. There will be part 2 of this. So for now we will end it here. Let me know if you are getting the approach behind solving these integrals. You need to identify that focal point where you have to focus and where the problem is designed from. Anyway, so we'll end it here, and I will post more of these videos for definite integration mode actually, because that is a very demanded topic. So thank you again, and please do subscribe to the channel and let me know if you have any suggestions in the comment section.